Awesome. Great, everybody. Well, welcome, welcome. I got a little feedback on my side. Cool. So, hey, hope you're having a great day. My name is Cedric. I'm an open source engineer coming at you from New York City. And in the building and getting started with AI track, we've got a wonderful demo and session for you today about building AI applications from your desktop with an open source tool. It's called the Podman AI Lab. It's a open source project, and it's part of the CNCF sandbox. So it kind of revolves around this kind of world of cloud native applications where I build something on my desktop, right? Containerize it so that anyone else can run it on their desktop. And then we can take that and move it to Kubernetes environments. And that's really important for AI because we want to have consistency and flexibility when we're building these applications. And as a developer, I want to start working from my desktop. And so we're going to talk about this tool and how you can use it on your Mac, your Windows, your Linux machine in order to work with open source models like Llama or Granite or whatever you would like to use, and then be able to build those applications and scale them up, all using container technology. So we'll go ahead and hop in. And today's schedule is going to be pretty brief since we've got about 30 minutes here today. But I want to provide you the session slides. So it's going to be red.ht/ai-lab-slides. And if you want to try Podman Desktop and do these demos that I'm doing today, I encourage you to check out the open source tool that's going to allow you to download a wide catalog of different Apache 2.0 licensed models. And what's that mean is that you have full permission and licensing in order to use them in your applications to be able to test and build out new features, whether it's RAG, multimodality, agentic, whatever you want to do with these models, you have the full permission to do so thanks to the power of open source software. So let's kind of hop in really quickly. The tool that we're using today is the Podman AI Lab. And it is a cloud native sandbox project, but these are the seals that are the mascots of this Podman AI Lab project. And a group of seals is actually known as a pod. And pod is also the most basic unit for running applications in Kubernetes or running pods on your own machine, which is one or more containers that share the same namespace. Now, a quick explainer about the tool. Podman is a container engine. Many of us have worked with Docker in the past if we're developers or operations or data scientists in order to take our application and essentially create its own environment, right? So that if I build an image, which is an immutable aspect of this application, I can give it to you, I could give it to someone else, and it already has those dependencies pre-baked in. So I would do a Podman run and run that container, not having to have downloaded specific dependencies or Python versions or Java versions. And it's open source, compatible with Docker. It's secure by default because of rootless ability by default. And it's a fast and light container engine. It's a little bit different compared to Docker, but if you want to get the full explanation on why we're using Podman today, I highly encourage you check out the video on the IBM technology page. That actually has a more detailed explanation from a really cool guy here on the architecture strengths. And you can also check out this video from Christian Lempa. So a little bit about the tool itself. But the thing is, we're going to be using the interface, which is Podman Desktop, to run our models and build out these AI applications. I won't talk too much here because I want to show you and not tell you. But behind the scenes, the app that we're using to build these applications is built with Svelte and Tailwind, as well as Electron. And we're able to essentially run these containers on any machine by doing a virtualization stack or, for example, on Mac, a Podman machine, which is a virtual machine that's running our containers because containers are inherently Linux. So let's talk about transitioning to this new era of AI, because with containers, we're able to run these AI models just like how we've been running traditional applications in the past. So this is the mascot for the Podman AI Lab. He's a cute seal, but it all starts with enabling developers to use models, right? And the big advantage of running models locally is, first off, convenience and simplicity, right? I want to be able to run my services, my apps locally, to be able to test them, to be able to build them. As a developer, I want to have things running on localhost, right? And so by taking, say, for example, a model that might be hosted by someone else and having to do authentication, some type of token key, et cetera, can be difficult for getting things spun up very quickly. And so by running models locally, I have ease of integration to be able to integrate with other services, databases that are running locally. And I have customization and full control of that model. And for, say, for example, my organization, we have data privacy and security, since no data is being sent to a third party or a hyperscaler or any type of cloud. In addition, it's really important from a cost control, because as a lot of us have seen when we're doing, say, for example, vibe coding or working with large amounts of prompts and data, these costs can kind of scale up pretty quickly, right? If we're paying for some type of model that we're using. But if we can do everything in-house, well, we're only limited to our resources. And for us, we're going to be running 8 billion parameter models today. Now, excuse me, it's allergy season here in New York City. The tool that we're using is the Podman AI Lab, which bridges your local development environment with containers to Kubernetes if you want to scale things up later. But we're going to talk about the adoption of generative AI for app dev. So the first idea is prototyping. So how do I evaluate which model to use and experiment with my data and benchmark, as well as how do I build that into an application, right? Connect to my data sources. Am I using RAG? Am I doing fine tuning, agentic, evaluating the flows that the application needs based on the data? And then the last part is operationalizing. We'll also take a look at that and how do we serve the model. But the first two steps can be overwhelming, right? As a developer, it seems like I've traditionally been working with non-data science objects and on artifacts, right? So my application is the .jar. How do I work with the .gguf, right? How do I work with these types of model types? How do I configure and set up a model server? And how do I connect my data to that model that's running locally, right? Do I have a Swagger interface, et cetera, et cetera? So we're going to talk about these two main steps as an application developer. How do I evaluate those models? How do I build an application with that model? And how do I do this all locally, right? I don't want to do things on my computer, and I want them to spin up very quickly. So that's why the tool is Podman AI Lab that we're using today, this open source tool that allows you to get inspired by AI use cases. So as a developer, you might not have experience with LangChain or LangGraph or any of these other frameworks that help you integrate with models and make calls to models. So we're going to show how to quickly get set up with these templates and explore a model catalog. So different open source language models from Hugging Face that are just a single click to download and run those locally. So run them in a container image, so you don't have to worry about any type of configuration or dependency management because they're running in a container, and playground environment, so testing out your prompts. So just like that, we're going to go ahead and hop into the demo, but I'll check the chat really quickly as we're doing that and see if there's any questions thus far. Bonjour, Jean. Thanks for joining from France. I see some other guys in the chat here. Thanks so much for being here. If you have any questions as we're going through this demo, please feel free to let me know. But as I said before, we are here at the Podman AI Lab. So it's an extension of Podman Desktop. There's a lot of different open source tools that we've contributed to the CNCF here from Red Hat, including Podman, Builda, Scopio, Bootsy. And all of these tools help developers and operations folks be able to containerize and deploy their applications in a production environment as well. And for us, we're using this open source project to get started with different use cases for AI. So what do I mean by this? Well, let's say that your organization is building out some type of Google Meet notes summarizer, right? Being able to take the transcript of all of our calls, be able to summarize that so that others can review. Or for example, take our enterprise data and add it to a RAG chatbot, right? So that users who have questions with documentation can ask in natural language, hey, how does this work on version 11, right? Be able to use RAG for that. And not only in, say, for example, Python, but say Node.js as well, or function calling. So let's say I want to integrate into an API that I have to, say, for example, make Slack requests, right? Or add meetings to calendars. Well, we can do an example of function calling. And it's not just natural language, right? Audio, computer vision, multimodal. And this works because we have a catalog of different Apache 2.0 models here that you can either download or import from Hugging Face, as I've done with, for example, DeepSeek, or trained my own model using InstructLab and gone from there. So what I want to show you is that I have this Granite 3.2 8 billion parameter instruct tuned model that's been quantized in a GGUF format. I know that's a lot, but all that means is that we've essentially gone to the Hugging Face repository, downloaded that model, imported that model. But instead of having to do all of those tasks, all I did was hit the download button. And in order to serve this model, all I can do is hit create model service, specify a port. And what it does is it creates a container that's going to run and mount our model and run this locally. So that, let's say, for example, I want to make a curl request in my terminal. Well, I would just open up my terminal, place that request here, ask what is the capital of France? And since that model is running locally, pretty quickly we'll get an answer back saying, hey, hopefully the capital of France is Paris. We'll give it a second here as it just started up. And what's important to note as I'm doing this is that this is a service that's running locally. So just as I have services for MongoDB, databases, et cetera, we have a service that's running this as an API so that we could also do this in a Swagger interface, ask, hey, what's the capital of France? And see what's happening here in the background, why the request isn't coming through. Hold on. So let's see. Well, good thing about this being a container, and so I can check out my different containers here, is that this one started a minute ago. And so at the kind of back end, this is Llama C++, which is a inference engine. There's other inference engines. Ollama uses the same thing, Llama C++. But what I'll do here, let me just go ahead and delete these. Maybe what might have happened is that if you have too many models running on your local machine, well, they all are loaded in your computer's RAM, right? And you only have so much RAM on your machine. So what I'll go ahead and do is I'll just run that again. So start this as a service. You can notice it picks a port that isn't already used by your applications or services. And fingers crossed, we're going to call that specific port again. And fingers crossed, fingers crossed. Awesome. So cool. Capital France is Paris. And we could do the same thing in our Swagger interface. So as a developer, as I'm building out these applications, I'm able to see all of the different endpoints that I can make post requests and REST API calls to this application to this LLM that's running locally. Okay, so that's just how we can integrate it into our local host, right? To run this model locally. Let's say I'm a Java developer. Well, I need that code to be able to integrate it into my application. So I have that here as well. I can add this to my application.properties, POM.xml, and create a service so that I can start using that model in my application. What if I want to start from one of these templates? Well, I want to show you guys the RAG chatbot. And just as a recipe to make pizza has ingredients for cheese, pepperoni, sauce, etc., we have the same thing for a RAG application. You've got the model service to run the model, the vector database in order to store the data in vectors, and the AI application as a front end in order to make those requests to the model and to the vector database. So let's kick this off. What we're going to do is we're going to essentially use that model that we've already downloaded or that we can import from Hugging Face, start an inference server, load in any configuration we need, and build our vector database and our front end and create this AI application. So specifically, we can open up the front end and not the vector database port. And here we've got a simple RAG demo. So the question I want to ask is, what happened to Marty McFly in the 1955 accident, ? And you're probably thinking, hey, I don't know what you're talking about, Cedric. What did happen to Marty McFly? Well, I've got a PDF here which has some unique enterprise data, right? So this is Marty McFly's DeLorean, right, from the very popular movie Back to the Future. And in 1955, he submitted a claim saying that, hey, I had an accident here, and I want to get some assistance and hopefully, get some coverage on my accident. And so what we're going to do, and I should have shown you at the beginning that, hey, a model isn't going to know about this data because it wasn't trained specifically on this. But if we provide a PDF, text file, some type of enterprise data into our AI application, then when I make this call to the model, well, it's going to go and search for different chunks or content in our vector database that might be similar to this information. It's going to retrieve that, and it's going to pull that into the prompt so that we can see it in our response back from the model, so that we're able to get an answer like this, that, hey, this happened in the accident, the total cost is this. And so as a, say, for example, insurance claim adjuster, I could go in and start to help that customer because I understand the specific information that I need to. right? But let's say if I ask that same question and I take off that content, then let's see what happens. We get a very generic answer, right? Marty McFly was nearly run over by his own father, George McFly. I don't even think that's in the movie, actually. But so it's kind of, a very generic answer that doesn't understand, hey, what happened in the accident based on that specific enterprise data. So this is a quick example, and I'll show you the source code behind this, because what's really cool as a developer is that I can start from this simple boilerplate template, and I could actually configure this and customize this for my own use case. Because at the end of the day, what we're starting from is a container file, so that we can go ahead and containerize this application. And we've got this RAG app. So this RAG app Python code, essentially what it's doing is we're working with LangChain, and we're also loading in our PDF. So we've got this document loader for PyPDF and text loader. And we're starting from a local model that we're running on our machine, as well as an embedding model. So a way to take our text and convert it into vectors. What we're doing is connecting to a vector DB client in order to split our documents. We're reading a file when, for example, I upload it, whether that's text or a PDF. We've got some simple front end to upload our document. And when we have that file that's uploaded, we're going to split it and populate that vector database with a simple kind of chunking strategy. And what we're also going to do is provide some prompt templates. Hey, you're an assistant and you can only answer the question based on the following context. And then we also have some logic here in order to be able to save the chat history. So essentially, that's how we're doing this AI application, right? We've got this simple template code. We've got a little bit of logic in order to kind of populate our vector database from a PDF or from one of those files here. And this is all pretty simple code here that we can kind of take and we can modify and we can make it our own. So we can quickly build an AI application just like this using only 7 dependencies here and being able to say, make those changes. And once I've made those changes, I can restart those containers in order to update and continually build my application that's constantly ready to be uploaded to a Kubernetes environment as well. I see Deepak has a question here in the chat. Can Podman AI Lab be used to fine-tune the models or hosting the local fine-tune models for verification purpose? Great question. So what he's referencing is that, a lot of models, right, understand a general amount of content. So they understand, hey, what is the history of France, right? Or what is some random facts about technology, right? But they haven't been trained on your specific data, right? So RAG is a way to add that information on top of the model. But what if you want to take that model and integrate it with that data so it always knows and you never have to tell it that new information? So let's say I have a fine-tuned model. So I have a model for my organization here. Let me go back to the catalog for Parasol, and you'll see what Parasol here is in a second. But I could import that as a GGUF, so a quantized model or a .bin model, or I could do fine-tuning myself. So a way to do that is with InstructLab. So it's a QLoRa-based technique in order to create essentially adapters to fine-tune your model. And so by doing that, you're creating synthetic data from your PDFs, from your documents using Dockling. And InstructLab is going to synthetically generate new data and be able to train that into the model. And so what you can do here is actually start InstructLab as a container and be able to initialize the project, download a teacher model, serve that model and chat with it, and be able to do that fine tuning. And so we have a resource here in the AI lab in order to do InstructLab fine tuning, as well as a local server. Let's say you're using Olama and you want to replicate the endpoints so that you can make API calls. Well, you can do that on the same port. And there's also playground environments and much more. But yes, InstructLab is the way to do that, which is included in the Podman AI Lab as a container. Now, a lot of us are working traditionally with text applications, right? Chatbots, et cetera, et cetera. But what a big use case is actually going through and using audio, for example, as a medium for LLMs, right? And now it's not just LLMs, but it's multimodal models as well. So let's say that I'm talking to my microphone. I could be a doctor or something like that in English, or maybe Peut-être je peux parler un petit peu en français, uh, any other language or something like that, and I have that audio file, right? Well, then I could go and I could build one of these applications that works with audio using OpenAI's Whisper, which is a model that they open sourced, and I could take that. Oh, failed to establish a new connection with the slash inference URL. Well, I'll have to go back and debug that a little bit. What may have happened is I started this application a little too early. Um, but I'll show you what the background is. Maybe we can do some debugging. But essentially, I could take that audio file that and transcript that, whether it's English or any other language, and be able to do that using not just language models, but these multimodal models as well. And so here's just a quick example of passing it to that's this is where the error was, but passing it to that model that's running locally as well. We containerize that and we're able to deploy that on our local machine or somewhere else. Now, I want to show you something new because a lot of us have seen a lot of basic template applications. But what I want to show you is an existing application that I need to add some type of AI capabilities to. So if you're a Java developer, you might be working with Spring Boot, you might be working with Quarkus. And so I have this Quarkus application here. And so I'm going to enable the developer mode so that I can make changes and I can see this application running. And so what it's going to do is essentially compile some stuff. It's going to run it with a hot reload so I can make changes. And what I want to do is actually connect to a model that I have running locally so that I can add some type of chatbot capability and use a little bit of RAG, a little bit of prompt engineering to help our users. So what we have here, and I'll zoom out here so we can see it, is a insurance dashboard. And here we have that same Marty McFly accident, but now it's kind of nice, it's beautiful. We've used an AI to kind of create a summary and express the sentiment of the customer, but we want the insurance adjuster to be able to chat in natural language with the information that's being presented, right? So what I want to do is specifically use one of these models. So specifically, it's going to be this Granite model, and I'm going to go ahead and replace that base URL, which could be a third-party LLM, could be using ChatGPT or something like that, and sending those requests. But I want to do this locally, right? So I don't have to pay for anything. I don't have to request hardware resources or billing cost or anything like that, so that I can, let's say, for example, refresh this and ask, where did the accident happen? So that as a insurance adjuster or an employee of the company, I don't have to go through and kind of make all these requests. You can actually see this in live action here, that when I made that request in the application, in the background, because we're using LangChain for J or any type of framework for making these calls, it turned that into a post request on my local machine. We've got here a prompt, a system prompt to say, hey, this is what you do, but also a claim summary. So we're using prompt engineering to either pull that information from, say, a database or pull it from our application, as well as the question that the user asked. You're probably wondering, hey, how does this work? Well, we created a service to make this happen, so that we're essentially using LangChains for J AI service to have the system message, have in variables the claim summary and the question being asked, and we're using the model running locally in order to get the response back that, hey, it happened at the intersection of Colima Road and Azusa Avenue. So it's a quick example of, hey, how do I take an existing application and add these AI capabilities? Well, there's a lot of ways to do so, from using LangChain for J, for Ollama, for any type of OpenAI API specification. And this allows us to quickly get set up. And I can do that because I've got, for example, this boilerplate code that is pretty much the same thing I showed you, but in a more simple fashion, right? This AI service, as well as this application.properties that I modified. So great question. Madhu, do you not need GPU on your local machine to run models? Surprisingly, you actually don't need GPUs, but it will slow you down significantly because of the processing rate that you can generate tokens. So as you can see here, I have GPU inference on my M3 Mac, but I've worked with these models before without having GPU inference. It is very slow, but what I recommend is that if you're wanting to work with GPUs, or sorry, with models, even if you don't have that GPU, look for a 2 billion parameter model. So by 2 billion parameters, we're decreasing the model size by almost 3 times. So you could have 3 times of a faster response rate as using a 8 billion parameter model, and still be able to get a decently valid answer from one of those models, and make sure it's quantized. Make sure it's quantized to 8-bit or 4-bit precision, and that'll improve your processing speed by 2 times compared to using an unquantized or uncompressed model. But that's my quick recommendations on that specifically. Now, the last thing I want to show you as we're kind of closing out here, now it's been a lot of fun, but I want to show you specifically the idea around containers and Kubernetes for AI ML, not just on my own machine, but on a Kubernetes environment, because we get all of these great benefits like agility, flexibility, and portability with our AI applications. But what if we want to scale things up, right? So what I want to show you is that as a developer, I'm using what's known as Red Hat's Developer Hub, but essentially it's what's known as Backstage. It's an open source project created by Spotify. But what we have here is that same application I was running locally, but we containerized it. So what we did is, for example, you can see this here. We fetched the repository, built it with Maven, created that container and synced that to the cluster, and then deployed that using Argo CD to our various different dev and build namespaces, so that they're all synced up. And anytime I make changes in the repo, that is synced out as well. So I want to show you the application running here, because this is perfect not just for local applications, but for applications that might be running in the cloud. So I'm going to put the app here. So demo app. If you want to try out the application in the chat. So what I have here is the same application, but now because we're running with OpenShift AI, our open source models or fine-tuned models in a distributed environment with NVIDIA GPUs like we have here, what we can do is essentially create these REST endpoints for my application to make the call and be able to summarize the claim. So you'll notice it's going to be a lot faster here once this kicks off, because we have these models running in a VLLM, which is a production-ready runtime, just like what we've been using for our local environment, which is Llama C++. So feel free to try out the demo application, but this kind of shows that you can take that application and use these various cloud-native tools in order to go from your simple source code to a container running on your local machine to a container running on your Kubernetes environment. And I can show you that here is that we've got this pod that's running. So it's a deployment, and we've got a service so that you guys can all access that application and be able to scale this out and build this as a container image, be able to do a security scan, et cetera, et cetera, et cetera, and think about all of these other things about AI applications beyond just your local machine. But with that being said, guys, I've had a very fun time today, kind of showing you how to build these AI applications, how to get into the source code, make those changes, and be able to containerize them and build them for wherever you want to deploy your applications. So you can use GPU acceleration, no matter if you're using Windows, Mac, or of course, Linux. And try out the Podman AI Lab. It's an open source project, again, at podman-desktop.io. Happy to help answer any questions here at this point, but you guys have been wonderful, and I appreciate you sticking on here with me. I've got a question from Gilia. How can I use both Podman AI and Ollama? So that's a great question. What I think Ollama and Podman AI Lab work well for is actually different use cases. So Ollama, I highly recommend for developers who just want to kind of try out models and integrate them into their applications. And so it's a great first step. But the thing is, let's say that you want to build those applications. Well, how do you have access to a playground? How do you have access to the Swagger API to make those calls and test out the REST endpoint and those template applications? Well, then you would go beyond Ollama and use the Podman AI Lab, which sets you up for success later on. Because with Ollama, you're kind of not really stuck, but you're kind of limited to your own machine. But with the AI Lab, you're kind of unleashed to go build a container image and deploy that somewhere. So they're two great applications just for different use cases. And so it's all up to you to figure out which is better for your use case. But for AI Lab, it's for containerizing applications and building those AI apps from your desktop to then, hey, deploy to Amazon or Azure or whatever cloud that you're using that works with containers. Awesome. Okay. Well, cool. Thank you guys. I see the love in the chat. I really appreciate that. And yeah, if you have any questions, let me see if I have a contact slide. Well, it's Cedric Clyburn on LinkedIn. If you scroll up the chat, you can see my contact information and you can also see the slides. But just in case, I'm going to go ahead and show the slides one more time. Awesome. Yeah. So if you want to check these slides out, I'll throw the link in chat again. But I appreciate you joining and enjoy the rest of the open source LLMs day. Today, we took a look at Granite as our LLM that was being used for the insurance application as well as the RAG application. But the freedom is yours to choose what you want to go with. And that's the beauty of open source software. That's what we do here at Red Hat. And so it was a pleasure. So I'll hang out here in the chat, but feel free to enjoy the rest of your day. And thanks again for coming.